Now, first of all, what is Chapter 8? Well, Chapter 8 is a continuation of Chapter 7. Okay. Can everybody see the PowerPoint? One person tell me yes, because I know you're not going to talk to me.
Yes.
Okay. So, sampling distributions. And what's going to happen here, I'm just going to write it out. I don't like the slides in Chapter 8 because they go around the world. Okay, so I'm going to show you what the difference is between Chapter 7 and Chapter 8. Chapter 7 would give us a question and say mu is equal to 20 and the standard deviation is equal to 5. And please find the probability of X being greater than 36. Let me fix that focus. That focus looks a little blurry. There we go. So we would draw a picture. And that would be 20, 25, 30, 35, and 15, 10, and 5. And you want to know greater than 36. Well, 36 is right there. And it would be that area right there that you're trying to find, which is 9999. So you would punch in your calculator second vars normal CDF, and then you would go from, if you have an older calculator, you would have to change 36 into a z-score. 36 minus 20 over 5. 36 minus 20 is 16, or what is it, 14? No, 16. 16 over 5 is equal to 3.2. So you would go 3.2 to 9999. Oops. And then if you had a new calculator, you would do 36 to 9999 with a mean of 20 and a standard deviation of 5. So your newest calculators, you would type in the 20 and the 5. The older calculators, you would have to change 36 into a z-score. All right, so that's what we did in Chapter 7. Just to recap what y'all did in Chapter 7, so we can make the transition into Chapter 8. Cats have been playing with the do-jigger again. Okay. I got one cat. He's a black cat, and he gets on this desk, and he just taps at the. He just thinks that this Word document here, he just loves to tap on it. And by the time he gets through tapping on it, it's like down to the table. So anyway, I know whatever's been messed up on my desk, I know which cat has been on my desk. So anyway. So Chapter 8. Chapter 8 is going to follow the same lines, except Chapter 8 is using information obtained by simulations. Okay, simulations. That's a L. That's a I. Simulations. What does that mean, Hubert? Well, basically, either they generate numbers or they go out and survey and research people, thousands of people and hundreds of people, and it comes back and we integrate this with chapter 7. So a question from chapter 8 will look different from chapter 7 like this. Mu is 20. Standard deviation is 5. If, and this is the, I'm going to put the highlighter in here, pink highlighter. If 10 or if 5 more people are surveyed, researched, whatever. I'm going to put surveyed / researched. What would the probability of X greater than 16? Okay, so that's the part that's going to be different. Okay, so chapter 7, you just found out greater than 36. Here, if 5 more people are surveyed or researched, what would be the probability that X would be greater than 16? In other words, they give you a what-if statement. And if they give you a what-if statement, that means that you're going to have to change the standard deviation. And the standard deviation and the mu is going to look like this in chapter 8. Mu sub x bar is going to be the same as that. Okay, so you might want to make a note of that. Mu sub x is going to be, x bar is going to be the same as mu. But the standard deviation of x bar is equal to the standard deviation given over the square root of n. And that is going to get pink highlighter because that is the difference between chapter 7 and chapter 8. So that means you might want to get your highlighter out and highlight it for those 5 or 6 people that are actually taking notes. Okay? So what do? Well, you draw a picture like always. And it look just like this. And that's 20, 25, 30, 35, 15, 10, 5. And they want to know, since you researched 5 more people, what would happen what was the probability of one of those people being greater than 16, whether it's a score or shoe size or whatever? Well, see, the pink was not included in the original information. The pink was not included here. Okay? Not included. Because the question will say, with a mean of 20 and a standard deviation of 5, blah, 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 blah is normally distributed. What if 5 more people were surveyed? In other words, after this was done, they surveyed 5 more people. So those 5 people doesn't have anything to do with the previous information. So that's the what if. So that's why you have to change the standard deviation. And the way that you do that, and that focus still is not right. That looks blurry. Is that blurry to y'all? Or does it look clear to y'all?
It's not really that blurry. I can read everything fine.
Okay. Well, that's a little bit better. Okay, so what do? Well, you got to change that. So the new standard deviation is going to be equal to 5 over the square root of 5. The old standard deviation is 5 over the square root of 5. And that's basically going to give you a new z-score. Okay? Because you're going to do it, you're going to change that new standard deviation into this, and you're going to do, and then you're going to change that 16 to a z-score. Or if you've got a newer calculator, you're going to put this in for your new standard deviation. And I'm going to write that on the next page. Okay? So this is the difference between Chapter 7 and Chapter 8. Now, this is the type of question I'm going to test you on. Now, you're going to have some homework questions that are going around the world. Okay? Just be prepared for that because I'll answer those questions when you send them to me. But as far as the meat of 8.1, I'm showing you what I'm going to ask you on a test. So I'm going to rewrite this on the next page. And I'm going to write mu is equal to 20. Standard deviation is equal to 5. And that is, consider that old information. Okay, because you're going to go out and research 5 more people. Okay, so I'm going to go out and if 5 more people are blank, surveyed, researched, beat up, whatever the question is, what would be the probability of one of those people being greater than or equal to 16? And that could be an age, it could be a, it could be a test score, it could be whatever. All right, and we draw our picture over here. $20, $25, $30, $35, $15, $10, and $5. And we redraw our 16 right there. And we want to know, out of those 5 people, how many of those, what's the probability of one of them or all of them or whatever the question will ask being above the test score or age of 16? So if you have an older calculator, you're going to have to change that 16 into a z-score. But the standard deviation is not going to be 5. Okay? Now, in Chapter 7, 5 would be okay. Chapter 7, if you had a Chapter 7 question, 5 would be okay. But since this is not Chapter 7, they gave you 5 more people to deal with. You've got to change and get a new. So I'm going to take my green marker and I'm going to I can't use dark green because if I use dark green, it'll look like black. So I've got to get a new standard deviation, which is called sigma x bar. And that's going to be equal to, we said, your standard deviation over the square root of your new number, which is 5. And I didn't mean that to be the same number. Okay, it's not going to be the same number all the time. I don't know why I did that. And somebody, well, I'll do it because y'all not going to tell me. So I'll just go ahead and do it on the calculator. I'll sit here for 5 minutes and y'all won't tell me. So 5 divided by 5 raised to the 0.5 power. And that's not right. That's supposed to be a x to the y 0.5. Yeah, that's it. And if I hit delete, it's going to delete. I hate these calculators. To the 0.5. All right, that's the same thing as 5 divided by the square root of 5. I'm going to put parentheses around that square root of 5 because the calculator may go into conniption. There we go. And I get 2.236. Okay, so our new standard deviation is 2.23606. I'm going to leave it in there, 2.236067977. Okay, so if you're using a new calculator, that's going to be your new standard deviation based on the 5 new people. If you're using an old calculator, you're going to use that 2.236 blah, blah, blah as your calculation. So older calculator, I got to do a new z-score. So z is equal to 16 minus 20 divided by my new standard deviation, which is 2.2360679, whatever, dot, dot, dot. Okay. And I'm going to get z is equal to, let's see what we get. So I'm going to take my handy dandy calculator, and I'm going to 16 minus 20 is -4. So -4 divided by second answer, and it should be a negative, and it should, I'm looking to make sure that yeah. And it should come out to be, yeah, -1.79. -1.79. So I've just changed that 16 right here into a -1.79. So you'd go from 1.79 to 9999. So if you got an older calculator, we're going to type that in now. And we're going to go second vars -1.79 multiplied to 9999. And of course, we can't change. We've got an older calculator. It's going to be 0 and 1. And paste. I get 0.96327. 0.96327. 0.9633. Okay. So let's look at a new calculator. Second, vars, normal CDF. And here you would type in, if it's a new calculator, Let me move this over. If it's a new calculator, you're going to say mu is equal to 20. Standard deviation is equal to 2.23 ... And then 16 to, let's lower parameter. And the upper parameter is 9999. Okay. So take my handy dandy calculator. And my lower is going to change to 16. And my mu is 20. And my standard deviation is I'm looking 2.23607. 2.23607. And it should come out to be just about the same. 0.9632. Now, in Chapter 8, the homework and the test will compensate for it being a little bit off to the 10,000th power. 10, 100,000, 10,000. Yeah, 10,000th of a power, 10,000th digit. I mean, 10 thousandths is really not going to be frowned upon. So, and that's basically what we're doing in 8.1. Now, when you read the homework or you read the book, it's going to go around the world telling you what we're doing. So that's why I just tell you at the beginning what we're doing. So that way, when you read all that stuff, you won't be thinking, oh, I'm confused. And it still might happen in the homework. So let's look at a possible question. I pulled this out of the notes. Here is a possible question right there. Example 1. So go ahead and write that down. And that is one of your test questions. Example 1. The IQ X of humans is approximately normally distributed with a mean of 100 and a standard deviation of 15. Compute the probability that a simple random sample is a group, okay, size 10, results in a sample mean greater than 110. So will that group of 10 people result in a mean greater than 110? So go ahead and get to it. Draw a picture. Get your new standard deviation and calculate it like you would Chapter 7. That's all there is to it. Oh my gosh. People, can y'all not find phone numbers on campus? Lord have mercy. I've got an advisee that has to, I guess I got to hold their hand. Good gracious. Are y'all not given a directory of phone numbers for the school, or can you not look it up?
I don't think they give it to us. I'm sure it's easy enough to look it up.
Well, hold on. I'm going to see if it's not on the dadgum website. Probably be get connected under y'all's tab. It'd be get connected. Oh gosh, Tri-County just logged me out. Oh God. There's got to be somewhere. I bet it's under Message Center. Look there. Do y'all have Message Center on y'all's website, TCTC? I don't know what y'all's student side looks like.
Maybe. I haven't really needed to use it, so.
I feel like I'm holding, oh God, Tri-County Tech is so stupid. If you stay on the website for too long, it locks you out and you have to get out of the, oh God, this is so stupid. You have to get out of the search engine and go to another search engine or close out that search engine. I get so sick of working for T-Rexes. Any of y'all work at a place where the technology is like 10 years behind, or the attitude of technology is 10 years behind? I'm just looking to see how easy it is to find something. Departments. Arts and Sciences. Nope. Title department. I wonder if there's a department directory. Look there. There it is. I'm going to save this. Send it to them. Download. Academic contact card. Have no idea where I sent it, but we'll send it to them. Academic contact card. I'll probably get a message back. Who am I looking for? Oh, Lord have mercy. I don't know. Maybe the Marine and the father in me is just going, you gotta look for yourself. Nobody's going to say anything. Yeah, shut up, Hubert. Uh-oh, I heard a baby. Who's got a baby?
I'm sorry, my microphone wasn't muted.
That's all right. Is that a baby? How old's baby?
He's 2.
Bless your heart.
Yeah, for real.
There's no way in Hades I could go through that again. Lord have mercy. I've got 2 kids, and I'm going to tell you something. I'm about ready to kick them both out. No, I'm just kidding. I got a one that's graduating Clemson. She just got a ring the other day. And then the other one is 14, and he's a guy, so a 14-year-old male knows just about everything. If y'all don't know that, 14 through 18-year-old males know everything.
Yeah, I bet.
That's why whenever you meet one, just go the other direction. Wait until they get to be about 26 or 27. And then hopefully they're growing out of some of the stupid, but you still have some that are 30 and they cruise them all. So,
Oh, yeah.
So you don't have much to pick from. I hate to tell you.
Okay.
All right. So anyway, let's go back to my question. There's the question. And I'm going to pull up my handy dandy do-jigger. And I'm going to just go ahead and draw it, and then I'll maximize it where y'all can see it. So mean of 100 and a standard deviation of 15 means draw the curve. And you're right, I'm not going to draw the curve because I've got my sheets of paper, just like one or two of y'all did. There that is. I told you you wasn't going to get away from these curves, but I guarantee you there's some people out there still drawing them each time. 110, no, 115. So that's 100. That's 115. That's 130. That's 145. Make sure I added right. And then on the left side, that's 85, 70, and 55. And they say, compute the probability that a new bunch of people, size n is equal to, results in a sample mean greater than 110. So they give us n is equal to 10. And I'm going to write that in pink because that is the difference between chapter 7 and chapter 8. And they want to know probability of x being greater than, and I think he's greater than or equal to, let me check. Okay, greater than 110. Okay, so let's just go ahead and graph it. Greater than 110. 110 is going to be somewhere in here. So I don't have my ruler. My son borrowed my ruler, and of course, he didn't bring it back. And that right there is 110. And I'm going to shade that with a orange marker. I'm pepper, I'm chocolate, I color outside the lines. So I'm just going to go ahead and tell you that right now. And that's going to be 9999. So if you've got a new calculator, you got everything there except you don't have your new standard deviation. So I'm going to take my green marker and I'm going to draw a line over here, new standard deviation, which would be sigma x bar is equal to what? Well, the old standard deviation is 15 over the square root of 10. And our new standard deviation is equal to, and I'll take my handy dandy calculator, and that's going to be, I'm going to do clear, and I'm going to do 15 divided by parentheses 10 raised to the 0.5 power. There. And close bracket. There we go. So I took 15 and divided by the square root of 10. See what y'all get. I got 4.743 blah, blah, blah. So with your new calculator or your old calculator, your new standard deviation is right there. So now, if you've got an old calculator, then you've got to change, and I'm going to write that I'm going to go over here and I'm going to put that in another color. Let's put it in orange. So old calculator, that's going to be 110 minus 100 divided by 4.74 dot dot dot. So that's going to be your new z-score. So I'm going to take my handy dandy calculator, and 110 minus 100, I can do that in my head, is 10 divided by second answer, which is 4.743, and we know it's going to be 2 point something. 2.11. Why'd you round it off, Hubert? Because I told you at the beginning of chapter 7 that z-scores were rounded to 2 places. So that's your new z-score. So if you got an older calculator, you're going to go from 2.11 to 99999. If you've got a newer calculator, you're going to do it like this. Second, large, normal CDF. And I'm just going to type in 110 and 9999 and 100. And my new standard deviation is 4.74. Did somebody write the rest of it out? Did anybody write it out?
Yeah, it's 4.74341649.
You are special, Miss Cameron. Enter. And enter. 0.0175. So your area right here is 0.0175. Now, a lot of you are saying, well, Hubert, that don't look right because the empirical rule. Well, when you're dealing with these problems, when you are given a new group, the empirical rule goes out the door. Okay? So just ignore the empirical rule. If they give you in chapter 8, if they give you a new n, then the empirical rule, you can't apply the empirical rule because the empirical rule is only with the given information of mu is equal to 100 and standard deviation is 15. Okay? As soon as you throw that new group of people in there, that you can't use the empirical rule. Okay? All right, let's do a nerd. Let's do that other example. The mean weight gain during pregnancy is 30 with a standard deviation of 12.9. So you would draw that picture. I'm going to go ahead and draw that picture. So that's going to be 30. And that's going to be 42.9. And that's going to be 55.8. Somebody check my math. And that's going to be 68.7. Somebody check my math, please. And I don't forget the other side. I'm just going to have to do 30 minus, is it 12.9? 17.1 minus 12.9, 4.2, and minus 12.9. Negative 8.7. And I bet you $1 I copied it down wrong. I bet it's not 12.9. Yeah, it is. So y'all check my math and make sure. Let me write down the rest of the information. An obstetrician obtains a random sample of 35 patients. So N is equal to 35. This is your new stuff. And they want to know in order to, their mean weight gain during pregnancy was 36.2 pounds. I'm reading the question again. Mean weight gain, 12.9 pounds. Weight gain during pregnancy is skewed right. An obstetrician skewed right means that most of the weight gain is early in the pregnancy. Skewed right would be like this. Okay. An obstetrician obtains a random sample of 35 patients and determines their mean weight gain during pregnancy was 36.2. Okay, so let's look at what we got. 36.2. I'm just gonna graph it right here. 36.2. 30 to 42 is 12. Half of 12 is 6. So there's 36. So we're talking about, they just asked for the weight gain, so they didn't ask for more or less. So if you're just going to find that z-score right there, that's going to be 36 point, what did they say, 36.2. So we're going to have to get a new standard deviation. So that means standard deviation of x bar is equal to, our old standard deviation is 12.9 divided by the square root of 35. So 12.9 divided by the square root of 35 raised to the 0.5 power. And that comes out to be 2.18. So our new standard deviation is equal to 2.180497977. So you can copy that into your new whatever. I thought they would say more than or less than, but they're just wanting that number. So I'm going to type that in, normal CDF, and you can just go one side or the other. I don't think I understand what they're asking. So that's going to be 36.2, 36.2, and 9999. Mu is equal to 30. And our new standard deviation is 2.180497. 2.18 0498. 0498. Paste and paste. So above would be 0.00. So above the 36.2 days or whatever pounds is 0.0022. So subtract 1. That means below is 0.979978. The survival rate of 59 and below on COVID. But we need a vaccine. Okay, so 0.9978 is on the left of 36.2 and 0.0222 is on the right. So we're talking 36.2 pounds. Let me read the question again. An obstetrician obtains a random sample of 35, their mean weight gain during, I would say it's unusual, yes, because look at the right-hand side. The right-hand side is 0.0022, so that means it's way up in here. 0.0022. So to me, 0 is less than a nickel. 00 is less than a nickel. So I'm going to go with unusual. Okay. Question, gripe, complaint. All right, I'm going to let y'all go early today. Y'all got enough to go on for 8.1, and you don't have to you don't have to, kill yourself to do it. Just, I think there's like 9 problems. So I don't think it's going to be that bad, but I don't know. I haven't looked at it. Let me get the roll right quick, and we will convene until Thursday.